Dear physics aspirants, right now I have the chapter motion in a straight line, and subtopic 3.7 is relative velocity. You must be familiar with experience of traveling in a train and being overtaken by another train moving in the same direction as you are, while that train must be traveling faster than you to be able to pass you. It does seem slower to you than it would be to someone standing on the ground and watching both the trains. In case both the trains have the same velocity with respect to the ground, then the other train would seem to be not moving all. To understand such observations, we now introduce the concept of relative velocity. So relative velocity, you will understand. Consider two objects A and B moving uniformly with average velocity VA and VB in one dimension, say along x-axis. Unless otherwise specified, the velocities mentioned in this chapter measured with reference to the ground of XA, O and XBO are positions of objects A and B respectively at time t0. Their positions XA, T and XBT at time t are given by XAT, XAO, VAT 3.12a, XBT is equal to XBO plus B VT 3.12v. Then the displacement from object A to object B is given by XBAT is equal to XBT is equal to XAT is equal to XB0 and minus XA0 plus VB minus VAT 313. Equation 313 is easily interpreted. It tells us that as seen from object A, and object B has a velocity VAB and VA. Because the displacement from A to B changes steadily by amount VB minus VA in each unit of time, we say that the velocity of object B relative to object A is VB minus VA. VBA is equal to BB minus VA 314a. Similarly, velocity of object A relative to object B is VAB is equal to VA minus VB 314. Here you will see the graph, position time graphs to two objects with equal velocities. You will see A and B. This shows VBA is equal to minus VAB 314c. Now we consider from special cases. If VA, you will see here, VB is equal to BA and VB minus VA is equal to 0, then from equation 313, XB T minus XAT is equal to XB O and minus XAO into as a full stop, and therefore the two objects stay at a constant distance XBO minus XAO apart, and their position time graphs are straight lines parallel to each other as shown in figure 316. The relative velocity VAB or VBA is 0 in this case. VBVA greater than VB, BB minus VA is negative. One graph is steeper than the other. They meet at common point. You will see. And common point, for example, suppose VA 20 meter per second, and XAO is equal to 10 meter and VB is equal to 10 meter per second, XBO 40 meter, then the time in which they meet at T is equal to 3s. Figure 317, at this instant they are both at a position XAT, XBT 70 meter, thus object A overtakes about BB this time. In this case, VBA and 10 meter per second minus 20 meter per second is equal to 10 meter per second, and minus VAB. Suppose VABB are the opposite signs. For example, if in the above example object A is moving with 20 meter per second starting at XAO and 10 meter, and object B is moving with 10 meter per second starting at VB 0 and 40 meter. The two objects meet at T 1 seconds. The velocity of V relative to A, VBA minus 10 minus 20 meter per second minus 30 meter per second is equal to minus VAB. In this case, the magnitude of VBA or VAB is equal to 30 meter per second is greater than the magnitude of velocity of A or that of V if the objects under consideration are two trains, then for a person sitting on either of the two, the other train seems to go very fast. Note that equation 314 are valid even if VA and VB represents instantaneous velocity. Here you will see the graph position times of graphs of objects will with an equal velocity showing the time of meeting position of graph of two objects with velocity on opposite directions showing the time of meeting. You will see here, and here we will see the graph of two objects with equal velocity. So these graphs will provide you lots of information. In next video I will provide you lots more. Till then, thank you.